Welcome. So we have next up Elliot Saba, who's a senior research engineer at Julia Computing, talking about building better binaries. Nice.
Yes, that's right. And I know because people have various things as their avatars on GitHub, it's not super easy to recognize the people that you may interact with online a lot. So I figured I'd wear this. It helps people kind of make the connection. I know I promised 10 tips for building better binaries, but really, just laying it out in a big list wasn't very interesting. So we're going to go with a more typical presentation here. So, in the beginning, we had PKG, and it was good, but complexity grew, and people wanted to install things on machines that weren't perfect copies of Jeff's laptop. And so, Kano wrote BinaryBuilder.jl, and we had a great idea back then. We said, why don't we reuse binaries from other projects where people have gone through all this work to try and provide binaries for people to install things on their computers. And so we built homebrew.jl, we built winrpm.jl, we built things for installing things through apt, yum, pacman, etc., and also building from source. But there were big problems with this. Building from source has uncountable problems. It's awful. I'm sure you guys have done something where you try to download a package, it tries to build it on your computer, and it breaks for some reason. It starts yelling at you about G4tran, missing symbols or something like that, and it's pretty awful. Even Homebrew, apt, WinRPM, these things have all had significant problems throughout the years. And indeed, the maintenance burden has been much higher than we ever expected. It also often requires sudo and such, and we'd really like to avoid that. And so the end result was that bin depth was pretty flexible. You could do a lot of things with it, but the failure modes were really bad. It was just, when it broke, it was hard to understand why it broke, and it was hard to fix it. And so we came up with a plan. What did we want to do? We wanted, first off, reliability. And in general, this means we want to strip out complexity. We want to make providing binaries for any kind of Julia package to be as simple and painless as possible. We also want it to be very easy to use. First of all, for the developers, but also first of all for the users, but also secondly for developers. And finally, we still want it to be flexible. We want to be able to build anything from a small little package like libog up to the GASP Cairo series of just constant breakage. And so, how are we going to do this? We got together, we argued about things a lot, we came up with brilliant dreams, killed those dreams, came up with more realistic dreams, and finally we ended up with just unpack compiled tarballs on the user's machine, right? It should be that easy. You just download a tarball, you extract it into a directory, and you're good to go. Doesn't require package managers, doesn't require sudo, doesn't require compilation on the user's machine, doesn't even require state. You just unpack it and you're done. To do this, we're going to build those tarballs using a set of cross-compilers. We'll make a little Linux image that has cross-compilers for Windows, cross-compilers for ARM, ARch64, et cetera, et cetera, et cetera, built for all the targets we want. And we're going to run it pretty much anywhere that you can get access to a Linux or sometimes Mac machine. And so before I go any further, we're just going to see what this looks like. So there's a package called BinaryBuilder. You can call BinaryBuilder.run shell, and that's going to get you into a shell environment. So we're going to see if I can switch over here.
Do you have to be inside a VM for that first, or does that start the VM for you?
That's a great question. So what's going to happen is I'm going to run it inside this guy here, and I think I'm going to have to make this significantly bigger. All right. Is that readable? All right. So if I say using BinaryBuilder, this is just on a machine that I have back at home that's just running normal Ubuntu Linux, and I say using, I already said that, BinaryBuilder.run shell. What it's going to do in this case is it's going to launch what is essentially a custom-built Linux distribution inside of a user namespace. User namespaces is the same containerization technology that Docker uses, so it's very fast, very lightweight. It's basically just a process that says, hey, I want to execute inside my own little universe right here. Here's the set of files that I'm going to use. Here's the processes that I'm going to launch, et cetera, et cetera. So if I say, ls-la, what I see is, well, I've launched this inside of a directory that doesn't really make sense. It's a package that I was working on, but let's make a new directory. Make directory test. Inside test, we'll touch a foo file. We'll echo hello JuliaCon. JuliaCoin, okay. Invest now.
You're definitely not making JuliaCon.
All right, so let's do that again. So what it's going to do is it's going to launch inside its own little universe, and it's also going to, the run shell function is also going to map the local directory into this environment. So you can see that the two files that I created, bar and foo, are there. I can echo yo into a new file, and it will exist there as well. If I say things like, hey, what kind of machine am I running on? It says you're a Linux machine running x86-64. And if I ask GCC, what's going on? It says, I'm going to try and build for x86-64 Linux GNU. You say, great, I could have done this outside of this environment. Why is this useful? The answer is because we can say things like, OK, I want to run on Mac OS now. And so what it's going to do is it's going to give me the exact same Linux environment. But if I ask it things like, hey, what am I right now? It says, oh, I'm running Darwin, and I'm compiling for x86-64. If I ask GCC, hey, who are you going to try and compile for? It's going to say that. And indeed, if I were to create a test.c file, and typing in front of everybody is probably not the best idea, but let's just do it anyway. So we make our own little test thing. We compile it. And we ask, what is that? And it says it's a Mach-O 64-bit executable. So GCC is indeed compiling something for a Mac operating system. If I were to try and run it, of course, it would not work here. If I exit out of here and ask it to run Linux, I have to tell it what architecture, x86-64. And then I do the same GCC thing. So close. Then we can actually run it because it's actually unexecutable. So what we have here is we have a system that's set up to kind of give you the compilers you want to build for the platforms you want very, very easily. And things just kind of get swapped out from underneath you when you want to compile for a different architecture. So what this looks like is we're going to use this system.
Quick question.
Yes?
Can you take that Mac OS binary and run it on Mac OS after that?
Yeah, I could. I'm running that. I mean, sure, we can do that.
Let's not do it live for time.
All right, yeah. I think there's quite a bit to get through. But yes, I could. We have plenty of binaries that are being built. This isn't smoke and mirrors. It actually works. Yeah. So the structure of this is that we're going to start with some kind of source code, some kind of build recipe for that source code, and we're going to feed it to BinaryBuilder that has all of these what we call compiler shards that get kind of swapped in and loaded in when you want to build for a certain platform. So I just showed you that we could build for 64-bit Linux or 64-bit Mac OS, but we've also got ARM Linux, we've got FreeBSD, all that good stuff. BinaryBuilder.jl, when you pass it this source code and this build recipe, is going to make what's called a build.jl file. This is pretty familiar for those of you who have used any kind of bin deps stuff before, and it's also going to generate tarballs for each one of those different platforms. The tarballs will have things like libfoo.dll or bar.exe inside of it. Those files will then be provided through BinaryProvider to the user's package. So we have kind of a three-step process. You first build your source code, and you bundle your source code, and you make a build recipe for it. Then you give it to BinaryBuilder. That generates tarballs in a build.jl file. Then you give that build.jl file to the user's, to the foo.jl, which will actually install it on the user's machine. And so we're going to kind of step through these processes and see what it looks like, how you do this, how you kind of go from 0 to 60 with binary dependencies. So we're going to start with what the source code and binary build recipe looks like. And first we're just going to look at an example. We'll learn how to run that example, and then we'll actually build something together. So a build tarballs.jl file looks something like this. You start out by saying, OK, I'm using BinaryBuilder. I'm building something called OGG. Here's its version. Here are the sources. The source is like a URL that then gets mapped to a hash because we want to be confident of what we're building. The next thing we'll do is we'll give it a little script. We'll say, hey, here's essentially a bash script. I will point out there are some variables in here that are just kind of auto-magically inserted for you. There's like a workspace, which is the root directory of wherever you're working inside of. There's a prefix, which is where things get installed to, and there's a target, which is the machine that's actually being built for. So this is a very standard AutoTools configure installation recipe, right? You say, hey, configure to be installed to this prefix for this computer. And for most simple packages, like this is about the level of complexity that you'll need. We'll see there are some cases where you need to be a little more clever or work around things that aren't so clever. Down at the bottom, we're going to say we can give a list of different platforms that we want to build for. When you say supported platforms like that just means try and build it for everything. Finally, we specify some products. We say, hey, there's going to be a library that comes out of this. The library is called libog. And you should look for it, and if you can't find it, say something, because we definitely want to have a library here. We can also have dependencies, meaning if this binary depends on something else that would have been built before in some other like binary builder output, then use that. Install it so that we can link against it. An example of this would be we're building libog here, but then libflac is going to use libog to open ogflac files, so the libflac builder would specify libog as one of its dependencies. And then finally, we take all that information, we just pass it to this big function called build tarballs. And build tarballs, the way you use this is basically, it's like a program. You run the Julia script of this build tarballs directly. So if we come back over here and we go to the builders folder that I have, og builder. All right, so if here I have a repository that has that build tarballs that I just showed you in a file. And so if I run build tarballs, and I say help, it's going to show me all the cool stuff that you can do with one of these files. There's quite a lot. I suggest you read through it sometime. It's kind of fun. But basically, you can specify targets that you want to build for. If you don't want to build for all of them, you can say, hey, be verbose, or hey, if something breaks, give me a debug shell, that kind of thing. Just as a fun example, let's do it. Let's do a verbose build for x86-64, Linux, GNU. So this is going to start the build process from that recipe that I gave it. And you'll notice that when I say verbose, it really is quite verbose. It's going to tell us everything that's doing. It's going to spit out all of the compiler invocations, all of that stuff. And then it's going to say, here's what I built, and here's any warnings that came out of it. So if we scroll up back to the very top, we'll just take a real quick tour through here. So the first thing it does is it says, OK, I'm going to check that everything was downloaded. I'm going to check that I have the compilers for the root FS, the compiler shards that you asked to build for. It goes through some things that it's parsed out from the command line that we're giving it, blah, 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 not very interesting. Moving right along, it says, all right, I'm going to start running like the configure thing that you gave me, the make thing that you gave me, and then it starts actually spitting out, like this is actually the configure script. This is what it looks like when you try and build a piece of software that uses AutoTools. From here on out, it's basically just compiler output. We're going to skip past that because it's not very interesting. And eventually, it gets down to this blue stuff. And this is where we have finished the build, and it starts looking at it and saying, OK, you asked me to build a libog. I actually built a libog. Let's make sure that you can, say, DL open it. Let's make sure that everything looks good. And then at the very end, it just says, here's all the files that I built, and here's what's going to be inside the tarball that we just packaged up and is ready to go. So that's kind of a whirlwind tour of that. We're going to talk about this a little bit more right after we talk about I said verbose is interesting. There's some environment variables that you can set to make things go faster with using Ccache and stuff. We're not going to talk about that because it's not super important. What I do want to talk about is what build tarballs is doing. So this build tarballs function, which we gave all that information to, it's basically going to use a backend to run that build inside the little build environment. The runners are just the various backends that we can use. I mentioned before that we use a user namespace by default on Linux. That's kind of like Docker. We also have an actual Docker runner, and we have a QEMU runner for running on OS X. That's an actual emulator that can run Linux stuff on Mac. So for that person who asked that question about whether it's going to start up a virtual machine for you? The answer is yes. It's extremely slow, though, so I don't recommend it quite yet. We still have some more work to do on speeding that up. The third step, which is the one that I wanted to talk about right now, is called auditing. So that's where that blue part where it says, okay, I'm looking for the libraries that got built and kind of inspecting them. It's going to take care of a lot of problems for you that you would otherwise run into when you're doing this kind of work. Both. So what it's going to do is it's going to do things like a dynamic library may try to link to another dynamic library, and it may get the path wrong because you have specified it may have specified the link at build time location, but when you move it over there, it isn't updated for the install time location. And so it's going to look through all the other libraries that it's seen, find one that matches the same name, and it will link it to that instead, which is kind of cool. It'll also check for ISA problems. So for instance, if you build a binary on your computer and your computer has, AVX2, the build process may detect that and it may encode those instructions into the actual binary. That's bad because if someone doesn't have AVX2 and they try and run that binary, it won't work. So what this will do is it will scan through all your binaries and say, okay, what instruction architectures are being used? If one is being used and it doesn't have a CPU ID instruction, meaning it can't kind of tell what it's working on and dynamically switch, then it will freak out and it will say, hey, this binary probably needs to have like a -march or something set in the compiler tools. Some build systems don't know that DLL files go in the bin folder instead of the lib folder, so it'll move things like that. Windows, you can't create symlinks if you're not an administrator, so it'll automatically collapse those and turn them into files. Just all the kind of like tiny stuff that you never want to have to think about, it does its best to try and do for you. A lot of the things, though, are set as warnings, not errors. So if you are having trouble with a binary package and you're like, why isn't this working? A good thing to do is go back through the build logs and just check for warnings, because sometimes you can find those kinds of problems embedded in there. So we're going to take a look at a slightly more complex example, Sundial's builder. We're just going to look at the builder. Well, great. All right. Good thing we have Google, right? So this is what happens when you're an early adopter of my stuff. You end up having your repository shown on a JuliaCon talk. So Sundial's builder is going to use a couple features that are pretty useful that I'm going to show here real quick. So the first thing is, in my example with libog, we only had a single source. We had a single URL mapped to a single hash. Here we actually have three sources. Two URLs that are going to get downloaded and hash checked, and then one that's not a mapping, it's just a string. This means I want you to mount something that's local. Usually it's like a folder with patches and stuff inside of it. If I go into here, we can see that there is in fact a patches directory, and inside of it there's a bunch of patches that are going to get applied during the build process. Sundial's script is much more extensive than the libog one was because there's a lot more to do. Part of the things it's going to do is things like apply patches to the source code that's in there. Other things it's going to do is it's going to build like sub-libraries and stuff. So you can do all sorts of crazy complicated stuff in here, up to and including having special cases for like, hey, if we're running on a 64-bit architecture, then we need to apply the ILP64 patch to this kind of thing, and stuff like that. There's CMake, there's all sorts of build tools that you might need. And finally, there's special stuff to do on Windows. So if target matches MinGW32, then we need to do extra stuff and things like that. So all this being said, the scripts that you can write are just full bash scripts. You can do anything that you want inside of here. And unfortunately, sometimes you do have to do kind of complex stuff to get it to build on all the different platforms. The upside is it builds for all these different platforms. And there are quite a few libraries that are going to be produced by this. Now, the reason we ask for this list of products is because, one, we want to make sure that we built it properly, but also, two, the output of running this repository is going to be the instructions for a Julia package to install the binaries. And so these library products are going to define variables that will be mapped to the location of the libraries that get installed. So for instance, when you run the output of this repository, it's going to give you a deps.jl file that will have things like libcolamd as a variable that points to the library that it needs. So when you define these things, you're basically saying, these are what I'm going to use, and we do our best to provide a seamless experience so that you build this. You use the build.jl file, and it's going to just give you what you want. And this thing does actually depend on OpenBLOS. So there's an example of a dependency. So it'll install OpenBLOS in the build environment before it tries to compile all this stuff so that it can link against OpenBLOS and all that good stuff. Any questions so far?
So that it will go and download and build it.
Right.
In Builder.
Yeah. So if we ran this file, it would build tarballs for sundials for the platforms that we have here. The output looks something like this. We get a bunch of tarballs, and then we get a build.jl file. And this build.jl file, you can tell I live in the terminal. The build.jl file looks something like this. So it says using BinaryProvider. That's kind of the flip side. BinaryBuilder is used to build things. BinaryProvider is used to deploy things. It's going to have all the products here, and then it has a list of Linux for this architecture, and this libc type is going to be downloaded from this URL, which is the Julia Diffie-Q Sundials Builder releases page, and then it has a hash for it. So basically, it's just a big dictionary that maps, okay, for this platform, you download this guy. For this platform, you download that guy. And then down here, it's just got some like install functions that it calls and stuff like that. It's very, this is very uninteresting. This file is basically the same for every single different project, and it's just going to have a kind of a boilerplate. You put in it generates the mapping here, and then it downloads and extracts it there.
And what were the dependencies, the last one you showed?
Great question. And hard question. So dependencies, for instance, here, this guy depends on OpenBLOS. We don't actually need to provide a dependency for it because OpenBLOS ships with Julia. However, for other pieces of software, you have to include the build.jl file for those dependencies as well. We have a better system that's being designed right now. I expect within the next couple months, we're going to have something that people can start trying that will make things a little more automatic. I'll get to that in a later slide. Any other questions? Yes?
So what if you have something you're building that requires a header file from a dependency?
Right.
Is that something you need to provide header files as?
Yeah. So this libog thing, did it install any headers? I'm not sure. You can't see that. Let's take a look. Usually, when we just do a make install, it installs everything. Libraries, documentation, header files, and we just glom everything together because a few extra kilobytes usually doesn't break the bank. Here, this libog guy, he did. So part of the tarball is all the libog headers. And when you provide a dependency, it's going to just download the tarball that this guy created, and it's going to extract it into that prefix, the place where it's installing. So everything should, quote unquote, just work. In that the tarball will get extracted into the builder environment, and then when you're trying to build, for instance, libflac, it's going to look for the libog header, and it will be in the place that it expects to look.
So you don't have to explicitly provide it, just install it in the install prefix and then put it there?
Yeah, usually. Some build systems don't do that, but usually. That's how we try to set it up. We try to set it up so well-behaved build systems work well with this. It just goes to show how few well-behaved systems there are. Yes?
So for certain kinds of software like MXNet and stuff like that, you can optionally specify whether you want to build it for the GPU or certain kinds of things. Where do you specify those kinds of special options while using binary?
Great question. So you can do pretty much whatever you want inside of these build tarballs files. So in this script, you can pass whatever kind of options you want. So it's entirely possible for you to provide whatever kind of options you want inside there. We don't yet have a good way to have like a single package that has options that you can kind of set inside of it. So right now you'd have to create kind of separate releases for like, here's the with GPU, here's the without GPU, here's the, whatever. You could, of course, the build.jl files that it generates, you can kind of choose which one you want to install on the user's, on the package side, of course. Yeah, we don't have like an options thing set up per se. All right, so let's actually build a package. So what we're going to do is we're going to start our own builder repository. So you can use this thing called so you could, of course, create a build tarball.jl file manually. But we like to streamline things, so we're going to use the wizard. So I'm going to make a glpk package. And we're going to run the wizard. And the wizard is basically an interactive setup where we can say, hey, I want to download this piece of software. I want to build this. Yep, this is the part that took the longest out of everything. No, actually, people are surprisingly eager to build these kind of things. So we're going to build glpk. So we're going to say, all right, I'm going to build something for all supported architectures, because why not? It says, please give me a URL. I say, here's a tarball. It downloads it. It says, would you like to download additional sources? In this case, no, because we only have one. Do we require any binary dependencies? Anything else that was previously built? We say no. And now it says, we're going to drop you into the cross-compilation environment. The first thing we're going to do is build for Linux x86-64 with the glibc. The prefix environment variable is where you want to install things, blah, 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 blah. It also says, hey, I notice you have a configure file. You should probably use this. So we say, all right, I blindly trust you. So we go into here, we run that. So it runs configure, and it looks like it worked. We say, all right, let's make it. There's an nproc environment variable for just this purpose. It builds, and it's done. Now, I have a warm C cache, so that's why it's going so fast. Normally, that would take a few minutes. So now it's done. I say make install. It installs everything, and I say, all right, well, I'm done. So I hit Control-D, and it says, this was your build script. So it kept track of what we typed in there, and it says, do you want to edit it? I say, you know what? We can condense this a little bit. We don't have to do this CD. We can put this right here. So I'll save that. You know what? Actually, let's make it so that, well, I saved it. So when you save it, it builds it again, and it says, you know what? That actually worked. And we built these build products. If I hadn't edited it, it would have jumped straight to this step 4. And it says, all right, I see a binary file called glpsol. I have no idea what that is, but I know that I want libglpk. So I say, all right, I want this. If I just hit done right now, it'll say, no, you really do need to specify something. So we say, all right, we want that. And then it says, all right, give me a variable name for this. So when you actually install this, what's the variable name to refer to this by? So we say, all right, this is libglpk. And it says, all right, we're now going to try and use the same script to build for Windows x86 or x64. This is probably not going to work, but it says, okay, let's go. So it builds it, and it runs, and there's an error. If I scroll up, it says undefined reference to GM-time-R, undefined reference to strr. I say, I can't deal with this right now, just disable this platform. And it says, yeah. So it says, all right, let's try it for ARM64 Linux, and that works. And it says, all right, so now we're just going to try everything else that you enabled. So we say, all right, go. And it won't do it verbosely this time. So it's just going to run it, and if there's an error, it'll yell at us. Otherwise, we get a little green check mark. And so while it's building all this stuff, we'll just talk a little bit about what the output of this is going to be. Thank you. So we're pretty much going to try and get a build.jl file or a build tarballs.jl file out of this. It's going to auto-generate it, give us a Git repository that we can use with that, and any platforms that it doesn't work for this case, we'll just disable. I don't think I'm going to have enough time to fix it live, but basically you just have to give it a little compiler defined to say, hey, this is building for Windows, so disable these functions, and this particular package can actually do it. God knows what's wrong with FreeBSD. I haven't had time to look at that yet. So it says, all right, we failed to build also for Windows 32 and FreeBSD 64. We say, OK, disable these platforms. Enter a name for the project. We're going to call it glpk. Enter a version number, 4.65. And it says, all right, here is a build tarballs.jl file. So scrolling all the way up to the top, it says, use this as your build tarballs. And it gives me all this stuff. It should look a little familiar to us by now. There's that sources, there's the script, there's the platforms. It kind of lists out all the ones that worked. And it also gives us the products and dependencies, and finally the build tarballs invocation. So we could copy paste that into a build tarballs.jl file. We can also use Travis to build this for us. So it gives you a Travis YML file. I'm going to say, nope, just give me a local Git repository. I want an MIT license. My name is Elliot Saba because I don't have my Git config set up properly, apparently. And wizard complete. It says your repository is all set up in here. And so if we were to actually go there, it has all that stuff that we need. So that's the steps that we go through in order to build something to build the tarballs. If we actually ran that, it would create the tarballs in the kind of products directory. And there's stuff. Well, I'm kind of out of time. So what I'm going. All right. If we just run it, then what it's going to do is it's going to be pretty silent as it's building it. We'll basically just see messages that say, hey, we're building this and that. And so it downloads the thing. As it downloads the thing, I'm going to open up a second tab so we can see. I'm going to open up a second tab so we can see what's going on. So it added a build directory and a downloads directory and a products directory. Inside downloads, there's the stuff that it needs. So it's got like the GLPK source code. Inside of build, it's got a directory for like each thing as it's building. It's kind of the workspace that it's working inside of. And then finally, inside products, we have the tarballs as they're being created. And so the last challenge for us is to actually host these somewhere and then provide the build.jl file for other people to download it. If you build it on Travis, that's all pretty much taken care of. There's one example that I'll show you here, which is the Sundials builder here. He has the Travis YML already set up. And so basically it says, hey, I want you to clone BinaryProvider and BinaryBuilder. The script I want you to run is just running build tarballs. And there's a deploy section here that takes it and deploys it to GitHub releases so that all he has to do is push up code and tag it. And then as soon as that happens, it just automatically gets deployed to releases here. You can download this .jl file, run it, and it'll just download the stuff to your directory. That's it. And thanks to Kano and Tony and Christopher and Stefan and all the people that helped out with this stuff. Yes?
Okay, so I apologize in advance because this isn't a question, but I think it needs to be said. Cross-compilation, so in my experience, is something you try once and then you question your life choices, so not even once. But I tried this. I built 2 binary dependencies in a day with it, and it's just great. So keep the magic coming. Thank you.
I just wanted to say thank you for building this whole binary builder thing. You showed Sundial's builder. It makes me look really cool. I still really don't know how to build packages, but like it looks like it works, and it works. I mean, and we tested on every single operating system, even like 32-bit Linux, and like it's awesome. Like, thank you so much for this.
So what do we do when cross-compilation is broken for a project and we can't figure out how to fix it?
Yeah, that sucks, right? So we have basically 2 options. One is to, so when I said we had like big dreams and we broke those and went to more realistic dreams, some of the big dreams are to have like full emulation layers built inside this. So we can use things like QEMU, we can use things like Wine and Darling and such to actually run those like native Mac or native Windows binaries inside of the Linux compilation environment. So if you can do that, then you can actually run things with cross-compilers, but running like the bootstrap steps and things like that, such that the project doesn't really need to know that it's being cross-compiled. That's one possibility. That's a little ways away. That's not mature yet at all. The other option is we can do the same kind of careful compilation that we've done for this kind of stuff, just natively, wrap it up in tarballs, and use BinaryProvider with it. So you can do all this work manually. It's just you have to be more careful because you have to do all those checks and all those things to make sure that it's actually redistributable and doesn't just work on your machine and no one else's. So for things like HDF5, for instance, that is not cross-compile friendly. So what we're probably going to have to do is we're just going to manually build it on different platforms, wrap it up in tarballs, and pretend like it was built with BinaryBuilder until we get something better.
Is there like a guideline on how to package something so that BinaryBuilder likes it?
Like
what the
No.
directory structure in your tarball?
No, half of it's in the documentation. The other half of it is known by like 3 or 4 people here at JuliaCon. So, you know, open up an issue and we'll see what we can do for whatever package you're interested in.
Cool, thanks.
Yeah.
So supposing I
Just,
find
nope,
this-
nope, nope.
Supposing I find a new library online and I want to now provide a Julia package that's a wrapper of this library. So now if I understand it correctly, there are 2 steps. First, you generate the builder, and then do you put it in your deps file, or what exactly is the process now?
Great question. So the first thing you do is you create that builder repository that we just did, like through the wizard, and then the wizard itself, when you run that, or so the stuff that, let me restart. You take the wizard, you put in the source, it helps you build the recipe, and then you have the recipe, the build tarballs.jl file.
Okay.
Then when you run that file, that's going to generate all the tarballs and also a build.jl file. That build.jl file, that's what you put in your package. That is the thing that will actually download and install stuff for whatever package you're interested in.
I see. Okay, thank you.
Yeah.
All right. Any other questions?
I have a complaint.
Yes. I'm looking forward to this.
It didn't work when I built Julia from source and tried to use my package. What are you planning to do about it?
You know, I think that's really the problem of whoever writes that Julia thing. So I think you should probably open an issue on the Julia tracker and tell them your build system is broken. And I think that blue whale guy will probably have to do something about it.
Yeah, so thanks for the package, and also thanks for the help with CXX-Wrap and getting that working. So I was wondering, for Windows, would there be any possibility of adding the option to build natively on AppFair to get MSVC binary dependencies?
I don't think we have any real plans to do MSVC built stuff. The reason being because we want to have kind of the all-in-one environment that runs on Linux to do this, to make it easier for us to maintain, and also easier for people to be able to run on their machines, right? So I think that if there's a reason why you need MSVC, I'd be interested to talk about that with you offline. But for now, we're going to restrict it to just compilers that can be run from the Linux environment.
There's also, sorry if I may
Go ahead.
add something quickly. Sorry, quick addition to that, there's a couple possible ways to get MSVC compatible binaries. So one is using ClangCL to get MSVC compatible ABI as well as options. So ClangCL is a way to invoke the Clang compiler to get the same behavior as the Microsoft compilers. Another option that we haven't looked into but may be possible is to use the actual Windows MSVC compilers and run them through Wine. Wine is the one emulation layer that actually kind of works. So that's an easier target in terms of what Elliot was talking about in terms of the pie in the sky, emulating everything. The Wine ones tend to work, so we may be able to do that sooner if it turns out that MSVC prop is actually required.
I have actually also a real question. I realized in getting cross-compilation to work in AutoTool script for Windows that there's like specific tricks you have to apply every time. Would it make sense to maybe introduce that into the wizard, like scanning for that, and if it's not there, add it automatically or suggest it?
Yeah, I'm interested in any of that kind of stuff. So come approach me offline and we can talk more about that.
Sorry. One of my collaborators and we've been trying to work on packaging and shipping, just Julia code as a standalone application. And one of the challenges we face is in trying to get a list of binary dependencies of not just the package you're working on, but all its dependent packages as well. So I was wondering if there's any plan to have like a list of binary dependencies that if you say using this package, and there is some place somewhere where we can find the list of binary dependencies that are needed to make it work.
Yeah, great question. Our plan for binary dependencies is to integrate them a little bit more into the general package way of dealing with things. So rather than having these build.jl files, you'll actually express your dependency in a bit of a more like orthodox or more formal way. And so the exact form this is going to take isn't fully hammered out yet, which is why I said, oh, it might take us a month or two to actually have this in your hands. But the draft plan right now is we'll do something like we'll have separate packages for these binaries that will then depend on other things. So you'll have kind of flac.jl, which will depend on libflac, which itself depends on libog. Whether or not these are actual Julia packages or something special like a first-class library idea inside of PKG3, we're not entirely sure yet, but it'll be something like that. So I imagine that would make it a lot easier for you to kind of walk the tree and figure out exactly what's going to get installed.
Yeah, we'd be happy to provide examples for you to help this.
Great. That's all I need. All right.
Okay, maybe we'll call it. What do you think? Just like speaker.
Thank you.